Hi, so it's my great pleasure now to introduce Jim Bridenstine. Um, the Mars Society strongly supported Jim for nomination for NASA Administrator. I think he has done a terrific job. He has greatly elevated and promoted the potential of the commercial sector to open the space frontier. He's relieved us of excessive constraints from overburdens from the Planetary Protection Program. And he has shown, NASA insisted, which is on something that the American people have wanted for a long time, which is a space program, a human spaceflight program that actually is going somewhere. So without further ado, let's hear from Jim Bridenstine.
Robert Zubrin, I just want to say thank you for having me at this great conference. And of course, the Mars Society does important work in advocating for really our generation going to Mars, and we need it. We need it very, very badly, and we're very grateful for the support that we get from the Mars Society. And of course, Robert Zubrin has really not just through the Mars Society, but even before, when we talk about things like Mars Direct, for example, and The Case for Mars, which is a book that Robert Zubrin brought into my congressional office when I was in the House of Representatives. And of course, I read it cover to cover, and then I said, wait a second, we need to get other members of Congress to read this. I said, can you get me more? And he brought me a whole box of The Case for Mars books. And then, of course, I was able to take those to members of Congress on the Science Committee and other places to get members interested in a Mars mission. And of course, a lot of that work from Mars Direct to The Case for Mars is now really NASA policy. The idea that we're going to use in situ resource utilization to learn how to live and work on another world for long periods of time. The fact that we're going to do a conjunction mission, and the idea that we don't necessarily have to have nuclear propulsion to get there. I want to be really clear. I do 100% support nuclear propulsion. I think it's a critical enabler for exploring more of the solar system than ever before. But there are a lot of things that we can do using technologies that exist right now today to get to Mars that are critically important. And we're all excited about so many of the discoveries that Robert Zubrin was talking about, the life on Mars and the potential for life on Mars going back decades now. But this idea that in the last couple of years we have found liquid water, what we believe to be liquid water, 12 kilometers under the surface of Mars, where it's protected from the radiation of deep space, where we have found that the methane cycles of Mars match the seasons of Mars, which is an indicator of life, not a guarantee, but an indicator. And we have found that complex organic compounds are all over the surface of Mars. And Robert Zubrin properly identified years ago, look, that's not even possible on the moon. But Mars is where that is possible. Now we know that, in fact, there are complex organic compounds all over the surface of Mars. And it goes back to this idea that we know that billions of years ago, Mars had an ocean in its northern hemisphere. 2/3 of the northern hemisphere of Mars was covered in ocean. It had a thick atmosphere and a strong magnetosphere. In other words, Mars was habitable. And all of these ideas that have been promoted now by the Mars Society for all of these years are now proving to be quite true. And it's got so many people throughout the world excited about what comes next. I want to be really clear, because as the NASA administrator, I really don't have any leeway here. I want to be clear. We have not discovered either life or ancient life on Mars. We haven't done that yet. But the probability is continuing to go up. And the more we continue to search, the more we find that all of the ingredients necessary for life as we understand it are there on Mars, or were there on Mars in the past. And of course, right now we have the first ever astrobiology mission in NASA's history going to Mars, where we're going to not just look at the surface of Mars and make assessments as to whether or not life is there or was there, but in fact, we're going to do technology demonstrators that could have a transformational impact for how we're going to explore Mars in the future. We've got ingenuity that is with perseverance. Ingenuity, of course, being the Mars helicopter that I think has so many people excited about the future. And it is just a tech demonstrator, but once it's proven capable, I think it could really expand our knowledge of Mars in the future with future missions. And of course, we want to make sure we do the sample return mission to be able to get an even better understanding of past of Mars's past, to include whether or not there was life there. So there's so many very exciting things that are happening right now as it relates to Mars. And of course, the number one thing that we want to do is send humans to Mars. That is the highest priority of the human spaceflight program. And I know that there have been people in the past who have disagreed, but I'll tell you, I really think that the quickest path to get there is the utilization of the moon. Not to get stuck at the moon, not to get bogged down in the moon, not to have all of our money go to the moon, but as a way to prove the capabilities, to prove the technologies, to show short-term success so that ultimately we can go to Mars. And when we think about what we're going to prove at the moon, the utilization of in situ resource utilization, we think about the idea that we're going to be able to use power. We're going to generate the capability to utilize power on the surface of the moon and habitation on the surface of the moon, learn how to live and work for long periods of time, prove out this concept with the gateway, which is not just about access to every part of the surface of the moon, but it's also a deep space transport that's ultimately going to inform how we get to Mars. So all of these things I think are important for a sustainable program for the moon that ultimately gets us to Mars. A couple of other things that I think are important to note. And I think Robert Zubrin brought this up very clearly, and he's right. It is exceptionally difficult to get consensus within the political arena for what NASA ought to be doing. And I'll tell you, if we look back at the space exploration initiative of the 1990s, where we were going to go to the moon and then on to Mars, and all of this money that got wasted and then it got canceled. And then we go to the early 2000s, we talk about the vision for space exploration, where we were going to go to the moon and then on to Mars, and then it got canceled. Tons of wasted time, tons of wasted money. One of the things that I really hope defines my time as the NASA administrator is the idea that we can build a consensus program that can last for decades. And that's ultimately what's going to be necessary. Not that it's going to take decades to get to Mars, but as much as we loved the Apollo program, the problem is that it ended. We need to create a program that's sustainable for the long term. And so in order to achieve that, we're taking a lot of the principles that were framed in Mars Direct. Things like we're going to go with commercial partners. We're going to go with international partners. We're going to do in situ resource utilization. In fact, right now on the Perseverance rover, our first astrobiology mission heading to Mars, we have MOXIE on there, where we're going to turn the carbon dioxide atmosphere of Mars into pure oxygen as a tech demonstrator. And I know Robert Zubrin and Mars Society, you guys have been advocates for this for a long time. Well, we're going to prove that we can do it. We're going to prove that we can do it on Mars, and ultimately that's going to lead to us taking humans to Mars and using the resources of Mars to learn how to live and work for long periods of time. But when we think about how to build this consensus, I'll tell you, this is one area where I hope over the course of time people can see what we're trying to achieve at NASA, and that is this. When I was in the House of Representatives, I was a member of Congress before I was the NASA administrator. There were some really crazy dynamics that got formed, and I'll just give you some of those examples. I showed up to the House, and it became very apparent to me that Republicans were foregoing to the moon and Democrats were foregoing to Mars. And because of that split, nobody was going anywhere. And what Robert just said, the fact that we actually have a program that's actually going somewhere now is critically important. Not just doing, an asteroid return mission and all of these other kind of things, but we have a human spaceflight program that is going somewhere. And in order to do that, we had to say, look, it's not just about the moon and it's not just about Mars. Let's bring people together. Let's do a moon to Mars program and all of the above strategy. And guess what? It is starting to work now in a way that I think is very positive. The other thing that was important when I got to NASA is that even before that, when I got to the House of Representatives on the Science Committee, Republicans were for human space flight and Democrats were for the Science Mission Directorate and robotic space flight. Um, Again, it's a false divide. We all can do more when we work together. So one of the things that I think is important to remember as we build a consensus-driven agenda, utilizing all of the tools and capabilities that were highlighted in Mars Direct, and the Case for Mars, which of course is the book that Robert gave me when I was in the House. Um, we have to, I think all of those concepts are important, but at the same time we have to build a consensus driven agenda that can last for decades. So we need to bring people together. So it's not the moon or Mars, it's both. It's not human space flight or robotic space flight, it's both. The other big challenge is people would talk about, well, it's are you for new space or old space? And I like to say, look, I'm for whatever gets us where we need to go. And one of the things that I think a lot of people saw was when we gave a date to get to the moon, it actually drove things significantly at NASA, and it compelled Congress to act in a way that it might not have otherwise supported. For example, when we said we're going to go to the moon by 2024, all of a sudden it affects the budget of NASA. Now we have a mandate. We need to build bipartisan consensus, which we have done. We get a budget request that is higher than any NASA budget request in history. And with that bipartisan consensus, we're able to get it funded. For the first time now since 1972, we have a human landing system funded to go to the moon. And by the way, that human landing system that goes to the moon is also capable of eventually going to Mars. It's a critical capability that we need to be able to develop. So we have a human landing system that is not only funded, we have 3 commercial companies that are doing public-private partnerships right now in the development of that human landing system. The base period here is going to end in February. We need to make sure that we get the appropriations. I know we have this election coming up and we're operating under a CR, but after this election, we're going to go into what would be called an omnibus appropriation bill. We want to make sure that we get the $3.3 billion that we requested for that human landing system in that omnibus appropriation, which we're working for every day. The key to getting that is the bipartisan consensus. So breaking down artificial barriers and saying, look, we can all work together to get these big, achievements complete. So we now have a human landing system funded, which is critically important. We've got public-private partnerships with companies that are distributed across the United States, again, driving bipartisan consensus. These new innovative companies are driving down costs and increasing access to space in a way that we've not seen before, which is, again, very positive. So all of these things conspire to say that we are closer today to getting humans to Mars than at any point in the past. And yes, the first step is going to be the moon, but ultimately we're going to the moon for a purpose. And this is enshrined in the President's Space Policy Directive 1, which now has bipartisan support in the House and the Senate. Make no mistake, because of a lot of hard work of folks at NASA, and I'm grateful to the entire NASA communications team and legislative team and all the folks that have worked so hard to build this consensus. But we're going to the moon for a purpose, that is to get to Mars. We're going to learn how to live and work on another world for long periods of time, which of course is what we're going to have to do at Mars. I understand the architecture is not going to be identical because Mars and the moon are very different. The value of the moon is that it's a 3-day journey home. And if something bad happens, we can make it home. I think Apollo 13 taught us that. If something like that were to happen on the way to Mars, it would be devastating, and a devastating kind of event on the way to Mars would shut down the program. And we don't want that. We want to build a consensus-driven program that ultimately has the prospect of getting humans to Mars for that first, period of time where you could have years, human life on Mars for years, as we anticipate the future. So many exciting things. Now, to build this bipartisan apolitical consensus that has just so people are aware, When I came to NASA, the NASA budget was about $19 billion, which, by the way, was really big um, for NASA given years past. But now the budget request before the House and the Senate right now is not 19 billion, it's 25 billion. Our current enacted budget is 22 billion, and we're asking for 25 billion, and we have bipartisan consensus for what we're trying to achieve. So we're still very hopeful that after we get past this election and once we're doing the omnibus appropriations, we will get that $25 billion budget that enables us to build the capabilities ultimately to get to Mars. Breaking down the stovepipes and getting people to work together has been challenging, but it's also been important, and it's also what's going to enable this program to move forward. A couple of other areas that I think are important as we build the consensus. People need to understand that the moon is about heliophysics, because it's a repository of data and information from the early solar system. Subatomic charged particles coming from the sun for billions of years hit the moon. The moon doesn't have an active geology. It doesn't have an active atmosphere. It doesn't have a hydrosphere. And because of that, anything that impacted the moon billions of years ago is today right where it was billions of years ago. So it really is about the study of the sun. It's also about the study of the Earth. When we think about the proto-Earth of the past and how it was impacted by Theia, and ultimately all of those objects that came from that impact, they eventually coalesced into this Earth-Moon system. We now know that this Earth-Moon system actually shared a magnetosphere billions of years ago in the past, when that magnetosphere from the moon that actually protected the Earth enabled the Earth to help start, it enabled life on Earth to prosper in a way that it might not have otherwise been able to. And of course, those magnetic field lines enabled oxygen from the Earth to actually make it to the moon, which explains why in many cases we've got, and those magnetic field lines terminate at the poles of the moon, which very well could explain why we've got water ice on the North Pole of the moon and the South Pole of the moon, and not just water ice, but also now we see rust on the moon, which we didn't know existed until just, quite frankly, a few weeks ago. And this idea where the moon and the Earth shared a magnetosphere back in the day, we didn't know that until just a few days ago, as a matter of fact. So all of these kind of things are informing us about how planets work and how they interact, and ultimately these are going to be important knowledge points for when we go to Mars. So the moon is about heliophysics, it's about Earth science, it's about planetary science, and it's about astrophysics. From the moon, we can do amazing science of the early galaxy, of the early universe. We think about, we're all excited about the James Webb Space Telescope, from which we're going to be able to see cosmic dawn, the first light in the universe after Big Bang, cosmic dawn. We have ideas what that looks like. We're actually going to be able to see it using the James Webb Space Telescope. But the value, of the far side of the moon from an electromagnetic spectrum perspective is that it's so quiet. It is so quiet on the far side of the moon. We're not going to be able to just see cosmic dawn, but we could in fact see the dark ages. After the Big Bang and before first light appeared, what did those dark ages, what did that look like? We're going to learn all kinds of things about physics that we've never understood before and might not still understand, but we can at least maybe have a better model for how it works. So I think these things are very positive. But remember, when we go to the moon, the purpose of going to the moon, yes, we're going to get heliophysics and astrophysics. We're going to get planetary science and Earth science, but more importantly than anything, we're learning how to live and work on another world with these other benefits as we go along, so that ultimately we can go to Mars. And Robert, I really appreciate you talking about how we've transformed the planetary protection guidelines. We're leading the world right there. And the reason is because what we are doing is about Mars. We're trying to get to Mars. And those planetary protection guidelines of the past would have said, look, you can go to Mars, but you can't take a human. Well, we want humans to go to Mars. That's the objective. And so we work towards that every day. So we're bringing people together. It's the moon and Mars. It's human space flight and robotic space flight. It's Republicans and Democrats working together. It's traditional space and new space working together. We drive the 2024 deadline. It increases the budget with bipartisan consensus. That budget gets passed by the House and the Senate. We have a human landing system now, not only funded, but we have 3 public-private partnerships developing the human landing system. Look, I know this stuff, it sounds like it's maybe not that hard to do, but as I think Robert correctly identified, getting the consensus necessary to get to this point for the last 2.5 years has not been easy, but we're there. And I want to reassure the Mars Society and my good friend Robert, I want to reassure everybody that why we are doing these things is so that we can send humans to Mars, which is, that's in the Space Policy Directive 1, signed by the president, that now has bipartisan consensus in the House and the Senate. Yeah, that's a very important question. And the answer is anything we can do that drives sustainability is important. And in my view, having reusable rockets is a key enabler of sustainability. But as Elon Musk will tell you, it's not just reusable rockets. They want reusable everything, which is tremendously valuable. I just saw they're getting ready to launch another Starlink mission. And that's going to be the 5th time that rocket has been used, and it will be the 3rd time that the fairing has been used. So the more we can reuse things, the more the costs come down and the more the access goes up. One thing that we have to remember is that Apollo ended because it was so expensive. So when we think about reusability, we have to have reusable human lunar landers. That means that there has to be a place where they can get serviced. How do they get maintenance, and how do they get fuel? And in my view, the best place to do that would be at the gateway in orbit around the moon. And what that represents is, think of it as not so much as a space station in orbit around the moon, which it is, but think of it as a reusable command and service module that enables reusable human landing systems. And again, the architecture that we're creating here initially is for the Earth, but we're going to need a similar kind of platform in orbit around Mars with humans for Mars when we go there as well. So we're trying to create an architecture that enables long-term exploration, development, and even creating a frontier and a sustainable habitation capability in orbit around the moon that can be replicated or even utilized to travel to Mars, I think is important. Reusability is key. We've got to have power systems on the moon. We need to have habitation on the moon. We need to have reusable transportation architectures to get back and forth to the gateway, and even reusable transportation architectures to get from the Earth to gateway and gateway to the moon. So I think all of these are important for a sustainable lunar and Martian capability for the future. The most expensive part of getting anywhere in the solar system is getting into low Earth orbit. Once you get to low Earth orbit, you're halfway to anywhere in the solar system. So there are a lot of concepts about using the hydrogen of the moon. We thought the moon was bone dry from 1969 up until 2009. Now I know there will be people out there, well, I knew that the moon had water ice. But we made this big discovery, hundreds of millions of tons of water ice. Well, water ice represents hydrogen. Hydrogen, of course, is rocket fuel, and it's available in hundreds of millions of tons on the south pole of the moon and a lot on the north pole as well. Well, look, if you can crack that water ice into hydrogen and oxygen, if you can have that hydrogen put into cryogenic liquid form and put it into orbit around the moon, that's a tremendously valuable resource for access to a lot of the rest of the solar system. So I think that the value of the moon is that the gravity well is 1/6 that of the Earth. So it's really hard to take off planet Earth. It's not that hard to take off the moon. We look at the Apollo program. We look at how really small engines, it took a very small engine to launch off the surface of the moon with Neil Armstrong and Buzz Aldrin, and of course the 5 moon missions that came after that. At the same time, there's no atmosphere on the moon, so you don't have all the aerodynamic fairings and all of the heavy equipment to get through the atmosphere. So if you look at the ascent module for the moon, it looks it looks like a, I don't know, like a Volkswagen Beetle or something. It's just a little capsule, and it's not aerodynamic, and it doesn't look that fancy, and it certainly doesn't have that much power, and it doesn't need to, because the moon is 1/6 the gravity well of the Earth, and it has no atmosphere. So you can easily get off the surface of the moon. And if we could get that hydrogen using power on the surface of the moon, get that hydrogen into orbit around the moon, that could very well. And this is not currently our plans. I'm just kind of casting a little vision here, but you could easily talk about sending a lot of different missions, different places in the solar system, if we could start from a very low gravity well like the moon, and in fact have the propellant necessary in orbit around the moon. As of this point, we don't really have any plans to send, rotating kind of architectures to Mars for the purpose of creating artificial gravity. I can tell you, I've read the case for Mars, and I understand, Robert Zubrin's vision for, spinning, a rocket body and tying it to the capsule and spinning them with a cord attached to them, and it creates just enough. It's a wonderful concept. There's probably room for that kind of technology demonstration, I would imagine, for sure. I think probably the maybe a more maybe not a better approach, but a different approach that we're working on every day is just going faster. So it's not just the microgravity; it's also the radiation. So the harmful physiological effects from microgravity and radiation are pretty damaging to the human body. But when you get to Mars and you're on the surface of Mars, the microgravity is largely mitigated or offset, or the countermeasure is the 1/3 gravity of Mars actually provides a lot of countermeasure to the problems of microgravity. And when you're on the surface of Mars, the radiation dose is cut in half by the simple fact that the radiation is only coming from above, not from below. So getting to these other worlds faster is more important than probably anything else. And the moon would be the same way. Being on the gateway for long periods of time, probably a lot more damaging than being on the surface of the moon, or even under the surface of the moon. Being on the surface of Mars, or even under the surface of Mars. So I think if we can get there faster, that's a key enabler. It also enables us to be able to explore further within the solar system itself. And I would think, one of the ways to get there faster is nuclear thermal propulsion, which we do have investments in, and then nuclear electric propulsion, which we also have significant investments in. But you're right, the human physiology is not designed for microgravity or high doses of radiation. It does, you lose 1 to 3% of your bone mass every year. Your vestibular system gets all messed up. Your ability to fight off disease, your immune system gets really messed up. There's all kinds of cranial pressure in the brain, and that affects your eyesight, could be permanently. The key countermeasure to this, though, is to get to another world. And that other world, of course, in this case would be Mars, because that is having the gravity well of Mars would be a key countermeasure. The quicker you get there, the more you reduce that exposure. So with that, I'll close out. I know I'm over my time. I just want to say thank you to the Mars Society. Thank you to Robert Zubrin for your advocacy, your very thoughtful writing, and the great work that you have done to help kind of focus NASA's mission where we can get it focused. And we will look forward to the great things that this group does in the future. So it's great to be with you.